It's a important chapter, as you see the next chapter also little bit deals about with the light. This is chapter number 10. This is chapter number 10 in your NCERT textbook, and chapter 11 also will deal certain aspect of light only. Now this light chapter deals with reflection and refraction. Reflection and refraction. Before discussing about the refraction, let us understand what is light. What is light? Light is an electromagnetic wave. Okay, light is an electromagnetic wave, and it travels with the speed of 3 into 10 to the power of 8 meter per second. Well, the speed of light 3 into 10 to the power of 8 meter per second will come handy to you in your when we will dealing with the refraction. Now it is not of much use, because first we will be dealing with the reflection of light. First we will be dealing with the reflection of light. Now we should know the nature of the light. Light travels in the nature of the light travels in a straight line. Light travels in straight line. This we should all remember. Hence, whenever we depict a light, we always depict it in a straight line. We will depict it in a straight line. Whenever we will be discussing about the mirrors and various kinds of mirrors, and then we will be discussing about how the light is falling on the mirror and how it's reflected back, etc. In all the things we will be denoting in a straight lines, because we know the light is traveling in a straight line. In your 9th standard also you might have studied that when in a pipe, if you see through the pipe and there is a candle in the end of the pipe, you will see that you can see the candle. Suppose you are looking from here. If you are looking from here, you will see that you can see the candle only if the pipe, a hollow pipe, through the hollow pipe, if it is straight. Now if I bend this pipe like this and put a candle here and wish to watch it from here, we will see you cannot see the light, because light will be traveling in the straight line and it will be visible to you. Anything is visible to you when you now in your class 10th, and probably you might all be or have already understood what is light and how the things are visible to you. But let us think, because we should also understand the practicality of it, that how can we see any object? An object, if it is a light source itself or a illuminated body, okay, like sun, bulb, like artificially we have bulb and then naturally we have sun, okay, and we may have fire, etc. All those things emits light and we can see it. But let us see our copy, our pen, okay, the blackboard, etc. How you can see? They are not emitting the light. Then how you are able to see it? We are able to see the light, these objects, because from any source of the light, the source of the light or illuminated bodies can emit lights, and these lights are reflected from various surfaces. Whatever the objects we see is basically we are seeing them because the light from any light source get reflected from those objects and then reaches your eye. Suppose this is a book. Now how you are able to see the book? We are able to see the book because there is a bulb in your home and the bulb is emitting light, and this light is actually reflected to your eyes. This is actually reflected to your eyes. Now then are you able to see? That also comes the concept. We also come to the concept that light is reflected. Light is reflected. Now how is it? We can prove that we only see when the light is reflected from any object, then only we are able to see it. As simply as that, whenever if you switch off the light, you are not able to see any objects in your room, although the objects are present there only. But why you are not able to see the object? Everything is dark. Why you are not able to see that? Because the source, you have switched off the source of light, and there is no reflection from those surfaces. Okay, there is no reflection from those surfaces. Even a transparent glass, suppose there is a transparent glass, sometimes we are not able to see the transparent glass. If it is very transparent, very clear, we are not able to see. Why? Because the object is there and the light actually passes through it. It is, you're seeing from this side, you're seeing from this side, and you're not able to see, because from the source of the light, suppose there is source of the light, there is a bulb, and the light rays from this bulb is falling on this glass, and the glass is so clear that all the lights which is falling on them are actually passed. There are many light will pass, because when a light source emits a light, it doesn't send a single beam, a single ray of light. It sends a bundle of light rays, which may call it as a beam, or we can also multiple light rays. These all are sent. All of them are just passing through the glass. That's why sometimes what happens, if there is a glass door, probably sometimes you might not be able to see that there is there's something present in there, and you may collide with the glass. If the glass is passing through the glass, that's why sometimes what happens, if there is a glass door, probably sometimes you might not be able to see that there is there's something present in there, and you may collide with the glass if the glass is very, very clear. So for any object to be visible to us, the light should be getting reflected from that surface and reaches our eyes. Okay, either it might be a source of light itself, or it should reflect the surface of the it should get reflected from the surface of the object. Now hence we come with the concept of reflection. Okay, it's a very important concept, reflection, and we will be dealing it in a great detail in this chapter. Now reflection, as I have told, that reflection is when a surface is there, okay, and any light falling on that object and then getting reflected. Okay, the light which is coming from the source, we call it as an incident ray, and the light which is getting bounced back from the surface or getting reflected is called as a reflected ray. This is a reflected ray. Reflected ray. Okay, now there are various kinds of surfaces. There are mirrors, there are other things, but we can see the reflection is not always same from all surfaces. We can understand that the reflection is not same from all the surfaces. If the surface is very smooth, very polished, you get a very regular reflection. You should understand that the reflection will be very regular, and in fact this kind of regular reflection only will give you a proper image in the mirror. Hence the mirror, you will always see the mirrors won't be rough. Now we will always draw the mirrors like this. The polished surface will be plain, and the other side, which is if you take a mirror, you will see the back side is painted. Okay, so back side is represented like this. Anywhere you will see, it will be represented like this. In your books also it will be represented like this. Now this is called as a regular reflection. Okay, and if the surface is not very plain or well polished, what will happen? The reflections, the incident ray fall in any way, the reflected rays will be irregular. Hence, as we see, the parallel rays are falling, and the rays are going parallel to each other without intersecting each other. Now here the reflection you see, the reflected ray may intersect each other, okay, in various different manner, not in a regular fashion. So this kind of rough surfaces will not give you any images. Okay, this is called irregular reflection. Irregular reflection. Normally whatever surface we see in our day-to-day objects such as books, pencil box, etc., we cannot see our face on them because there are 2 points, 2 things. What are these? The surfaces are irregular and they are not well polished. Well polished surface only reflects most of the light. Otherwise what happens, some of the lights are also absorbed by the object. Okay, absorbed by the object. We can also deal with you might have already understood in your previous classes why we see different colors, why something is blue, something is yellow, something is red, because it reflects a particular type of light and absorbs the all other light. For example, something is yellow means that is reflecting the yellow light and all the others are absorbed in that. Okay, all the others are absorbed in. That's a different concept, because today we are only dealing with, in this chapters we will be dealing with the reflection and laws of reflection, etc., in various kind of mirrors. So we will stick to our part, but it's a good for your knowledge that why certain things are seen in different colors. Now you will say that the books are how irregular. My book is very good, so I maintain it very nicely, etc. My pages are very plain and but what happens is the irregularity which I am showing in this can be a microscopic level also. Example of this paper, you might be seeing it's very plain and all, but if you see it microscopically, the surface is not plain, it is rough. When you expand it and when you see it in the microscope, you will see it is rough. Hence, it won't give you that proper reflection like a mirror. In a mirror, should be completely plain. Okay, but then also sometimes it is very you maintain it very nicely. Suppose you are putting keeping it very new, then also you will see some of the plates. Now if you clean it very nicely, you can see a certain bit of reflection. Okay, you can see a certain bit of reflection. So this concept I am telling you because I want to make you understand about the plane surface regular reflection and irregular reflection. Whenever we are not able to see any image in any of the objects in our day-to-day use, is because the surfaces are irregular, hence we won't be able to see the proper image on them. Okay, now before understanding the reflection, let us know the laws of reflection. Laws of reflection. There are two laws of reflection. First I will make you understand with the diagram. Suppose this is a mirror. I take it this is the opaque part and this is a reflective part. Now the light ray is falling like this, incident ray is coming from there and it's getting reflected this. Now this point where the incident ray is falling on the mirror, point of incidence. Okay, points of incidence. Now if we draw a perpendicular from the point of incident to the mirror, this is the mirror. Now perpendicular means 90 degree. You see, 90 degree. Perpendicular to the mirror. You understand what is to whom this is perpendicular. This line is drawn from the point of incidence perpendicular to the mirror. This is called as a normal. Now we are familiar with the terminology. First, this is an incident ray. This is called, as I have told you, this is reflected ray. And this is the normal. New thing which you have learned is normal. Now the laws of reflection deals with these three things. Okay, first law of reflection says that angle of incidence. This is angle of, now you can see where I have drawn the incidence. Angle I have drawn it between the incident ray and the normal. So this is called the angle of incidence. And the same thing we do with the reflected ray and the normal, it is called the angle of reflection. This can be denoted as angle of incidence and angle of reflection. Now the first law says angle of, sorry, I have drawn angle like this. The angle should be drawn like this. So I will cut it. Angle of incidence and angle of reflection. The first law says the angle of incidence is equal to angle of reflection. Angle of incidence is equal to the angle of reflection. This is the first law. It will be followed in all the mirrors, let it be spherical mirror, let it be plane mirror, anywhere. This law will be, that's why it is called as a law. It will be followed in all kind of reflection. Angle of incidence will always be equal to angle of reflection with respect to normal. You should be understanding with respect to normal, that you will be clearing when we will be dealing with reflection in the spherical mirrors. Why this normal is so important, you will understand. Okay, now the second law, this is the first law. The second law is the incident ray, the normal, you know what is the normal, and the reflected ray. These all three are remain in the same plane. What do you mean by this? Remain in the same. This is the second law. First law is an angle of incidence equal to angle of reflection, and the second law says the incident ray, normal, and the reflected ray all fall in the same plane. Now to simply understand this is, suppose I have taken a table, okay, and I'm able to make the incident ray fall along with the surface of the table, and I've kept a mirror here. Okay, now it will be reflected by the mirror. Now to simply make you understand, now I will draw a normal perpendicular to the surface, perpendicular to the plane mirror. This is this is incident ray, this is reflected ray, as the arrow diagram shows you, and this is the normal. Now these all line in the same plane means, suppose this is a table and I am able to shoot a incident ray along the surface of the table, then the reflected ray also will be reflected along the surface of the table, and the normal will also be lying on the surface of the table. That is what is called is all the three are lying in the same plane. Suppose what I mean to say is, if the angle of incidence is coming along the surface and the reflected ray cannot go below the table, no, this is not possible, as the law says that the incident ray, normal, and the reflected ray all should lie in the same plane. Okay, now